March 15, 1945. Dawn breaks gray and cold over the shattered landscape of the German Rhineland. Steam rises from bomb craters filled with rainwater, while the acrid smell of cordite still hangs in the morning air. American Lieutenant Colonel James Morrison of the 820th Engineer Aviation Battalion stands ankle-deep in rubble that was once Luftwaffe airfield Y-64, his breath visible in the chill as he surveys acres of twisted steel and pulverized concrete. The previous night's bombing had been thorough. What the Germans had spent 3 years perfecting, reinforced runways, hardened aircraft shelters, fuel depots, now lay in ruins. Morrison kicks at a chunk of German concrete, noting its thickness, its quality. Around him, his men are already unloading the first trucks of an endless convoy stretching back toward the Rhine crossing points. 48 hours, Colonel, calls out Master Sergeant Tony Kowalski, consulting his clipboard against the strengthening light. Division wants fighters operating from this field in 48 hours. Morrison nods, his eyes calculating distances, drainage patterns, sight lines. Somewhere in the rubble lies the foundation of what his engineers will transform into something the German military minds never conceived possible. The sound of diesel engines grows louder as bulldozers lumber toward their positions, ready to begin the most audacious engineering feat of the European campaign. By March 1945, the German war machine was crumbling under the relentless pressure of Allied advances from both east and west. The Rhine barrier, once considered impregnable, had been breached at multiple points. American, British, and Canadian forces were pouring across Germany's last natural defensive line, racing to reach Berlin before the Soviets. But speed meant everything, and speed required air support closer to the rapidly moving front lines. The Luftwaffe, once the terror of European skies, was now a shadow of its former self. Fuel shortages had grounded most remaining aircraft, while experienced pilots were either dead, captured, or flying obsolete machines against overwhelming odds. German airfields, those magnificent concrete installations that had projected Nazi air power across Europe, were being systematically destroyed by their own retreating forces or pounded to rubble by Allied bombers. Yet these same airfields represented something extraordinary to American military engineers. Each represented months or years of German engineering expertise, millions of tons of high-quality concrete, and strategic positioning that German planners had selected for maximum tactical advantage. The concrete itself was remarkable, thick, reinforced, and designed to withstand the weight of heavy bombers and the stress of constant military operations. The challenge facing the advancing Allied armies was unprecedented in military history. Traditional warfare doctrine called for establishing secure supply lines and forward operating bases before major advances. But the collapse of German resistance was happening so rapidly that conventional logistics couldn't keep pace. Fighter squadrons were flying missions from airfields hundreds of miles behind the front lines, reducing their effective range and time over target areas. American military engineering doctrine had evolved dramatically since the early days of the war. The lessons learned in North Africa, Italy, and Normandy had created a new breed of combat engineer, men who could build, destroy, and rebuild infrastructure under fire. The Army Corps of Engineers had developed revolutionary techniques for rapid construction, while aviation engineers had mastered the art of turning any flat surface into a functional airfield. The secret weapon in this engineering revolution was something called pierced steel planking, known to the troops as Marston Mat after the North Carolina town where it was first tested. These interlocking steel plates, punched full of holes to reduce weight while maintaining strength, could transform rough terrain into aircraft-capable runways in a matter of hours. Each plank measured 10 feet long and 15 inches wide, weighing just over 66 pounds, light enough for 2 men to handle yet strong enough to support fully loaded bombers. But PSP represented more than just a technical innovation. It embodied a distinctly American approach to warfare, the belief that overwhelming industrial capacity and engineering ingenuity could solve any tactical problem. While German engineers had spent years building permanent concrete installations, American engineers had perfected the art of temporary construction that could be deployed, moved, and redeployed as battlefield conditions changed. The psychological impact on German military observers was profound. Captured Luftwaffe officers repeatedly expressed amazement at the speed of American airfield construction. One German pilot, shot down near Aachen, told his interrogators that watching American engineers work was like witnessing industrial magic. They couldn't comprehend how runways appeared overnight where none had existed before. This capability had been demonstrated repeatedly across the European theater. In Normandy, aviation engineers had constructed operational airfields on the beaches within days of the initial landings. In the rapid advance across France, entire fighter groups had leapfrogged forward, establishing new bases faster than German forces could mount effective counterattacks against them. The spring of 1945 brought a unique convergence of tactical necessity and engineering opportunity. As Allied armored spearheads penetrated deeper into German territory, the gap between frontline units and their air support grew increasingly problematic. Fighter aircraft, with their limited fuel capacity, needed forward bases to maintain effective close air support for advancing ground forces. Bombers required secure airfields for the final assault on remaining German industrial targets and transportation networks. German military engineering represented the pinnacle of defensive construction. Their airfield designers had created installations meant to last decades, with concrete runways thick enough to handle the heaviest aircraft and reinforced to withstand direct bomb hits. Underground fuel storage systems, hardened maintenance facilities, and sophisticated drainage systems represented millions of man-hours of expert construction work. The irony was not lost on American engineers. Here were perfectly positioned airfields built by their enemies to exacting military specifications, now lying in ruins but retaining their fundamental strategic value. The location selection had been brilliant. These airfields commanded approaches to major cities, controlled river crossings, and provided coverage for transportation networks. German military planners had chosen their sites with the same tactical considerations that American air commanders now required. Traditional military engineering would have required weeks or months to rebuild such facilities. Standard American construction doctrine called for clearing debris, surveying the ground, importing materials, and beginning systematic reconstruction. But the rapid pace of the 1945 campaign made such conventional approaches impossible. By the time traditional reconstruction was completed, the front lines would have moved hundreds of miles eastward. American innovation lay in recognizing that these bombed airfields contained something invaluable: millions of tons of high-quality concrete. Rather than viewing the rubble as debris to be cleared away, visionary engineers began seeing it as raw material for rapid reconstruction. The concrete that German engineers had so carefully mixed, poured, and cured could be crushed, graded, and reused as foundation material for new runways. This insight required a fundamental shift in military engineering thinking. Instead of starting from scratch, American engineers would cannibalize German installations and rebuild them using American techniques and materials. The German concrete would provide the foundation, while American pierced steel planking would create the aircraft-capable surface. The technique required unprecedented coordination between different engineering specialties. Heavy equipment operators would crush and grade the German concrete. Survey teams would lay out new runway alignments optimized for prevailing winds and tactical considerations. Construction crews would prepare the crushed concrete base and install drainage systems. Finally, specialized teams would lay thousands of interlocking PSP panels to create the finished runway surface. The logistical challenge was staggering. Each reconstructed airfield required hundreds of tons of pierced steel planking, trucked forward from supply depots along increasingly stretched supply lines. Heavy construction equipment, bulldozers, graders, rollers, and crushers, had to be transported across rivers and through areas still contested by German forces. Fuel, spare parts, and construction materials competed for transportation priority with ammunition, food, and medical supplies for frontline units. Yet American industrial capacity made the impossible routine. PSP production facilities in the United States were turning out millions of square feet of matting material. Specialized transportation units moved equipment and materials with assembly line efficiency. Most remarkably, aviation engineer battalions had developed standardized procedures that allowed the same basic techniques to be applied regardless of local conditions or specific airfield configurations. The speed of these operations amazed even experienced American officers. What had taken German engineers months or years to construct could be demolished, redesigned, and rebuilt in days. The psychological impact extended beyond pure military considerations. It demonstrated American industrial and engineering superiority in the most concrete possible terms. German prisoners of war, assigned to labor details at these reconstruction sites, watched in fascination as their former airfields were transformed using techniques they had never imagined. Many had been construction workers or engineers in civilian life. They understood the complexity of the work they were witnessing, which made American capabilities seem even more extraordinary. The broader strategic implications were profound. Rapid airfield construction eliminated one of Germany's last tactical advantages, the hope that extended supply lines might slow Allied advances. Instead, American air power kept pace with ground forces, providing continuous close support and maintaining pressure on retreating German units. From a human perspective, the men of the 820th Engineer Aviation Battalion were ordinary Americans thrust into extraordinary circumstances. Master Sergeant Tony Kowalski had been a construction foreman in Detroit before the war, building automotive plants for Ford and General Motors. His experience with industrial construction schedules and heavy equipment made him invaluable. But nothing in civilian life had prepared him for rebuilding airfields under potential enemy fire while working against impossible deadlines. Private First Class Miguel Santos from San Antonio brought different skills. His family had worked in demolition and concrete crushing for highway projects across Texas. When Santos first saw the bombed German airfield, he didn't see destruction. He saw the finest aggregate material he'd ever encountered. German concrete was mixed with precision that exceeded most American civilian construction standards. The proportions were perfect, the curing had been meticulous, and the reinforcement patterns showed sophisticated engineering knowledge. Lieutenant Robert Chen, a recent engineering graduate from MIT, represented the new generation of military engineers. His theoretical knowledge of materials science and construction techniques complemented the practical experience of career soldiers. Chen immediately recognized that the German concrete could be recycled more efficiently than traditional quarried stone, requiring less crushing energy while producing superior foundation material. The human drama extended beyond individual stories to encompass entire communities of specialists working in perfect coordination. Radio operators maintained communications with advancing combat units, ensuring that runway construction priorities matched tactical requirements. Heavy equipment mechanics worked around the clock, keeping bulldozers and crushers operational. Supply sergeants performed logistical miracles, ensuring that construction materials arrived precisely when needed. From a tactical standpoint, rapid airfield construction represented a revolution in military doctrine. Traditional warfare separated construction and combat phases. Armies would advance, consolidate positions, build infrastructure, then advance again. But the 1945 campaign collapsed these phases into simultaneous operations. Engineers were building airfields while combat units continued advancing, creating a rolling wave of infrastructure that kept pace with the fastest armored spearheads. The tactical advantages were immediately apparent to frontline commanders. Fighter squadrons could provide close air support with response times measured in minutes rather than hours. Ground attack aircraft could make multiple sorties per day instead of being limited by fuel considerations for long-range missions. Wounded soldiers could be evacuated to rear-area hospitals much more quickly when transport aircraft could land at forward airfields. German tactical doctrine had assumed that advancing armies would outrun their air support, creating windows of opportunity for counterattacks. American airfield construction techniques eliminated these windows, maintaining continuous air coverage even during the most rapid advances. This capability proved psychologically devastating to German forces, who found themselves constantly under air attack regardless of how far they retreated. The technological innovation represented by pierced steel planking reflected broader American industrial capabilities. Each PSP panel was manufactured to precise specifications using standardized production techniques. The interlocking system required engineering tolerances that could only be achieved through mass production methods. Quality control procedures ensured that panels manufactured in different factories would fit together perfectly when assembled thousands of miles away. The holes punched in each panel served multiple engineering purposes beyond weight reduction. They provided drainage for surface water, reducing the risk of ice formation in cold weather. The perforations created mechanical bonding points with underlying foundation materials. Most importantly, the whole pattern was calculated to provide maximum strength with minimum material usage, a classic example of American engineering efficiency. Transportation considerations had shaped PSP design from the beginning. Each panel was sized to fit efficiently in standard military trucks and transport aircraft. The relatively light weight meant that more panels could be carried per vehicle, while the interlocking design eliminated the need for separate fasteners or specialized installation tools. 2 soldiers could handle and install each panel, reducing the skilled labor requirements for airfield construction. The leadership decisions that enabled rapid airfield construction reflected uniquely American military culture. Traditional military hierarchies emphasized following established procedures and avoiding risks. But American engineer officers were encouraged to improvise, adapt, and find creative solutions to unprecedented problems. This cultural flexibility proved essential when standard techniques proved inadequate for the unique challenges of 1945. Colonel Morrison's decision to use German concrete as foundation material represented exactly this kind of innovative thinking. Military manuals contained no procedures for recycling enemy construction materials, but Morrison recognized the practical advantages and took responsibility for the results. His superiors supported this initiative because it promised faster results than conventional approaches, even though it required techniques that had never been attempted before. The German perspective on American engineering capabilities evolved from skepticism to grudging admiration to something approaching awe. Oberst Heinrich Weber, captured while defending the approaches to the Rhine, had been a civil engineer before the war. He had supervised construction of several Luftwaffe airfields and considered himself knowledgeable about military construction techniques. His interrogation reports provide fascinating insights into German reactions to American engineering methods. Weber initially dismissed American construction as temporary expedients that would prove inadequate for sustained military operations. He predicted that PSP runways would fail under the stress of heavy bomber operations, that improvised drainage systems would flood during spring rains, and that hastily constructed facilities would require constant maintenance. These predictions proved completely wrong, and Weber's subsequent reports show increasing amazement at American engineering effectiveness. The speed of American construction particularly astonished German observers. Weber had overseen airfield projects that required 2 years from initial surveying to operational status. Watching American engineers transform bombed installations into operational airfields in less than 48 hours challenged his fundamental understanding of military engineering. He repeatedly asked his interrogators to explain American construction techniques, clearly hoping to understand capabilities that seemed almost supernatural. From an enemy intelligence perspective, rapid American airfield construction represented a nightmare scenario for German military planners. Traditional defensive strategies assumed that attacking armies would require extended periods to establish air support capabilities. German forces could retreat to successive defensive lines, knowing they would have windows of opportunity when Allied air support would be reduced due to range limitations. American engineering eliminated these opportunities. German intelligence reports from early 1945 show increasing desperation as planners realized that Allied air support was actually intensifying as ground forces advanced deeper into German territory. Every destroyed German airfield was being rebuilt faster than German engineers thought possible, and often with improved capabilities over the original installations. The moral dimension of recycling German construction materials carried profound psychological significance. American engineers were literally taking German military infrastructure and transforming it into the foundation for Allied victory. The concrete that German workers had poured with such pride was being crushed and reused to support American aircraft that would continue bombing German targets. German prisoners working on these construction projects experienced this transformation directly. Many reported feelings of surreal displacement as they watched their former airfields being rebuilt using techniques that surpassed anything they had known. Some described it as witnessing the future of construction technology, while others found the experience profoundly demoralizing. The technical excellence of American construction methods impressed even hostile observers. German engineers noted the precision of PSP panel installation, the effectiveness of American drainage techniques, and the sophisticated coordination between different construction specialties. These observations appear in intelligence reports filed by German agents who managed to observe American construction activities from hidden positions. The technological superiority demonstrated by American engineers extended beyond pure construction techniques to encompass integrated systems thinking. German airfield design had focused on individual components, runways, hangars, fuel systems, without optimizing their integration. American approaches treated the entire airfield as a unified system, with each component designed to support overall operational effectiveness. PSP technology particularly fascinated German engineers because it solved problems they hadn't realized existed. German concrete runways required substantial maintenance and were vulnerable to bomb damage. PSP surfaces could be repaired quickly by replacing individual panels, while damaged sections could be identified and replaced without affecting adjacent areas. The modular design allowed for expansion or reconfiguration as operational requirements changed. The industrial scale of American PSP production amazed German intelligence analysts. Their reports estimated that American factories were producing enough PSP to construct dozens of complete airfields simultaneously. This production capacity exceeded anything German industry had achieved, even during peak wartime production. The implications were staggering. America could apparently construct airfield infrastructure faster than German forces could destroy it. From a strategic leadership perspective, American airfield construction represented the ultimate expression of industrial warfare. Traditional military strategy emphasized capturing and holding territory. American strategy emphasized maintaining offensive momentum through superior logistics and engineering capabilities. This approach made traditional defensive planning obsolete, as defensive positions could be bypassed and isolated rather than confronted directly. The coordination required for rapid airfield construction reflected sophisticated American military organization. Engineer Aviation Battalions worked seamlessly with combat units, supply organizations, and Air Force personnel. This integration required communication systems, standardized procedures, and leadership structures that German military leaders found impressively complex, yet remarkably effective. German military analyses of American engineering consistently highlighted the role of individual initiative within structured organizational frameworks. American enlisted men were encouraged to solve problems creatively, while officers focused on coordinating multiple simultaneous activities. This leadership style produced faster results than traditional Germanic emphasis on rigid hierarchy and detailed pre-planning. March 16th. 600 hours. The transformation begins with a sound that German engineers would never forget. The deep mechanical growl of American heavy equipment starting their engines in perfect sequence. Bulldozers, graders, crushers, and rollers emerge from morning mist like industrial predators, their diesel engines warming in the cold air while operators conduct final equipment checks. Master Sergeant Kowalski consults his pocket watch and nods to Lieutenant Chen. They have exactly 42 hours remaining. The first phase involves controlled demolition of structures too damaged to salvage. American explosive specialists place charges with surgical precision, bringing down damaged hangars and control towers in carefully calculated sequences. Each explosion sends debris tumbling in predetermined directions, away from areas marked for runway construction. The sound echoes across the Rhineland landscape, announcing to anyone within miles that American engineers have arrived. But the real breakthrough comes when Private Santos fires up the massive concrete crusher, a mobile industrial plant that German engineers have never seen before. This machine, manufactured by American heavy equipment companies for civilian highway construction, represents the technological gap between German and American industrial capabilities. It can process tons of concrete rubble per hour, reducing massive chunks of German construction to precisely graded aggregate material. The crusher's rhythmic pounding creates a hypnotic industrial symphony. German concrete disappears into its mechanical jaws and emerges as perfectly sized stone chips, ready for use as runway foundation material. Santos monitors the output with expert eyes, adjusting settings to optimize the crushing pattern. The quality of German concrete actually makes his job easier. The materials were so well mixed originally that they crush into superior aggregate. Meanwhile, survey teams led by Lieutenant Chen are laying out the new runway alignment. They work with speed and precision that amazes watching German prisoners. Using techniques developed for American highway construction, they establish grade lines and drainage patterns within hours. The new runway will be oriented differently from the original German installation, optimized for prevailing winds and tactical considerations rather than the defensive priorities that shaped Germany and construction. Heavy equipment operators begin the most spectacular phase of the operation. Bulldozers push enormous piles of German concrete rubble toward the crusher, creating organized chaos that somehow maintains perfect efficiency. Each operator knows exactly where to deposit his load, when to return for more material, and how to avoid interfering with other equipment. The coordination resembles a carefully choreographed industrial ballet. The first loads of crushed German concrete spread across the prepared runway base create an emotional moment for everyone involved. Here is German military engineering, literally ground up and repurposed to serve Allied victory. The symbolism is not lost on anyone. American engineers are using German materials to build the airfield that will support the final assault on German resistance. But symbolism yields quickly to practical urgency. Great operators spread the crushed concrete with mechanical precision, creating perfectly level surfaces within tolerances measured in fractions of inches. Compaction rollers follow immediately behind, pressing the recycled German materials into dense, stable foundation layers. Water trucks spray precisely controlled amounts of moisture to optimize compaction characteristics. The pace accelerates as teams find their rhythm. What seemed impossible in the planning stages begins to appear routine as American engineering capabilities reach full deployment. Equipment operators develop intuitive coordination, anticipating each other's movements and optimizing workflow patterns. Supply trucks arrive with clockwork precision, delivering fuel, spare parts, and construction materials exactly when needed. German prisoners assigned to labor details watch in fascination as their former airfield transforms before their eyes. Many had worked on the original construction years earlier, spending months preparing concrete forms and reinforcement patterns. Now they witness their work being recycled in hours using techniques they never imagined possible. Some express grudging admiration for American ingenuity, while others find the experience profoundly disturbing. The technical challenges multiply as construction progresses. Underground fuel lines and electrical systems must be relocated or replaced. Drainage systems require complete redesign to accommodate the new runway alignment. Lighting systems, communication networks, and emergency equipment all need installation or renovation. Each system requires specialized expertise and precise coordination with other construction activities. Lieutenant Chen discovers that German engineering drawings, captured intact from the airfield administrative building, provide invaluable information about subsurface conditions and existing infrastructure. The German documentation is meticulously detailed, showing utility locations and construction specifications with Teutonic precision. This information allows American engineers to avoid costly mistakes and accelerate their construction schedule. The most critical moment comes when the first loads of pierced steel planking arrive from supply depots. These standardized panels represent months of American industrial production, shipped across thousands of miles of ocean and hundreds of miles of war-torn European countryside. Each panel must be perfect. There are no second chances when aircraft begin landing operations. Installation of PSP requires different skills from foundation preparation. Teams of soldiers work in coordinated patterns, laying panels in precise alignments while ensuring perfect interlocking connections. The work is physically demanding, but not particularly difficult. Each panel weighs just over 66 pounds and requires no special tools for installation. 2 men can handle each panel, but coordination between multiple teams determines overall installation speed. As the first sections of runway surface take shape, the transformation becomes visually dramatic. Hours earlier, this area had been bomb-cratered wasteland. Now, a perfectly level runway surface emerges from the chaos, ready to support the heaviest American aircraft. The PSP surface has a distinctive appearance, industrial, functional, and unmistakably American in its engineering philosophy. March 17, 1400 hours. 32 hours into the construction marathon, the impossible begins to look inevitable. The main runway surface stretches nearly 4,000 feet with PSP panels interlocking in perfect geometric patterns that create an almost hypnotic visual effect. But Lieutenant Colonel Morrison knows that completing the runway surface represents only half the challenge. An operational airfield requires dozens of supporting systems, each requiring specialized installation and testing. The breakthrough moment comes when Sergeant Kowalski's team completes the fuel system installation. Working from captured German engineering drawings, they have located and reconnected underground fuel lines that survived the bombing. American portable fuel pumping equipment integrates seamlessly with German underground storage tanks, creating a hybrid system that combines the best of both engineering approaches. The first successful fuel flow test draws cheers from tired construction crews. Communications installation proceeds simultaneously with final runway preparations. American radio technicians string antenna systems and install navigation equipment that will guide aircraft to the new field. The work requires delicate precision. Radio frequencies must be coordinated with other Allied airfields to prevent interference, while navigation aids must be calibrated to provide accurate guidance regardless of weather conditions. But the real test comes when advance elements of the 354th Fighter Group arrive to inspect their new home. Colonel Robert Scott, the group commander, lands his P-51 Mustang just as construction crews complete the final PSP panel installation. His aircraft touches down on German concrete foundation covered with American steel planking, creating the symbolic culmination of the entire project. Scott's inspection reveals the extraordinary quality of the construction work. The runway surface is perfectly level, with drainage systems that channel water away from aircraft operating areas. Taxiways connect the main runway to aircraft parking areas created from recycled German concrete. Even hastily constructed maintenance facilities show attention to detail that exceeds minimum military specifications. The psychological impact on German observers reaches its peak when the first American aircraft begin routine operations. What had been their airfield jousts, just 48 hours earlier, now hosts enemy aircraft with efficiency that surpasses anything they achieved during years of occupation. German prisoners watch in stunned silence as P-51 fighters taxi past positions where Messerschmitt 109s had been parked just days before. German engineering officers questioned by Allied intelligence teams provide insights into their reactions that will be analyzed for years afterward. Oberst Weber admits that American construction capabilities exceed our most optimistic estimates of what could be achieved under ideal conditions. He notes that American engineers accomplished in 48 hours what German construction crews would have required weeks to complete, even with unlimited resources and no threat of enemy action. The technical achievement becomes even more remarkable when independent inspections confirm the structural integrity of the hastily constructed airfield. American aviation engineers subject their work to stress tests that simulate months of heavy aircraft operations. The combination of recycled German concrete foundation with American PSP surface proves not only adequate, but superior to many permanently constructed airfields. The operational test comes when fully loaded P-47 Thunderbolts begin takeoff operations. These aircraft, carrying maximum fuel and ordnance loads, represent the heaviest stress that any runway surface might encounter. The PSP panels distribute the load perfectly, while the compressed German concrete foundation provides stable support that shows no signs of settlement or deformation. Weather conditions provide an additional test when spring rains begin falling during the final construction phases. American drainage systems, integrated with surviving German infrastructure, handle the water flow without creating operational difficulties. Aircraft continue landing and takeoff operations in conditions that would have grounded operations at many conventional airfields. The moment of ultimate validation arrives when a formation of B-25 Mitchell bombers requests permission to use the airfield for an emergency landing. One aircraft has suffered battle damage that makes reaching its assigned base impossible. Colonel Morrison authorizes the landing without hesitation, confident that his engineers' work can handle even this unexpected stress test. The B-25 landing succeeds perfectly, with the damaged aircraft rolling to a stop on the PSP surface that shows no signs of distress. Ground crews immediately begin repairs using portable equipment that operates as effectively on the temporary airfield as at any permanent installation. Within hours, The repaired bomber is ready for return to active operations. News of the 48-hour airfield construction spreads rapidly through Allied military communications networks. Other Engineer Aviation Battalions request detailed technical reports, hoping to replicate the achievement at their own construction sites. The techniques pioneered at this obscure German airfield become standard procedures that accelerate airfield construction throughout the remaining months of the European campaign. The human cost of the achievement becomes apparent as exhausted construction crews finally rest after completing their impossible mission. Many soldiers have worked continuous shifts for nearly 2 days, sustained by determination to prove that American engineering can overcome any challenge. Medical personnel treat cases of exhaustion and minor injuries, but morale remains extraordinarily high among men who know they have accomplished something remarkable. The strategic implications become clear as fighter squadrons begin routine combat operations from their new base. American air power maintains continuous pressure on retreating German forces, while close air support for advancing ground units operates with unprecedented efficiency. The gap between frontline positions and effective air support has been eliminated through engineering innovation. Master Sergeant Kowalski surveys the completed airfield as evening shadows lengthen across the PSP surface. 46 hours earlier, this had been a bombed wasteland. Now it hosts active combat operations that will continue until final German surrender. The transformation represents more than engineering achievement. It demonstrates American capabilities that German military planners never imagined possible. The immediate tactical impact of the 48-hour airfield construction proved even more significant than Allied planners had anticipated. Within 72 hours of completion, the airfield was hosting over 200 aircraft operations daily, providing close air support for advancing ground forces and interdiction missions against retreating German columns. Fighter squadrons operating from the recycled German base achieved response times to ground support requests that averaged under 15 minutes, compared to previous averages of over an hour when operating from distant rear area bases. German military resistance in the sector collapsed with stunning rapidity. Intelligence reports from captured officers revealed that constant air attack from the nearby American base had made organized retreat impossible. German units attempting to establish defensive positions found themselves under continuous air surveillance and immediate attack. The psychological impact proved as devastating as the physical damage. German soldiers reported feeling completely exposed and helpless against omnipresent American air power. The success triggered an immediate reassessment of Allied engineering capabilities throughout the European theater. General Omar Bradley's staff issued urgent requests for detailed technical reports on the German concrete recycling techniques, while British engineering officers arrived to observe American construction methods firsthand. Within weeks, similar projects were underway at captured German airfields across the advancing front. The German High Command's reaction bordered on panic. Intelligence intercepts revealed heated discussions among German military leaders about American engineering capabilities that exceeded their wildest fears. General Alfred Jodl, Chief of Operations Staff, reportedly told subordinates that American construction speeds made traditional defensive planning obsolete. If every destroyed airfield could be rebuilt in 48 hours, then the Wehrmacht's strategy of trading space for time had become meaningless. American industrial production responded to the success by accelerating PSP manufacturing and developing improved installation techniques. Factories that had been producing 50,000 square feet of pierced steel planking daily increased output to over 100,000 square feet. Specialized transportation units were organized to ensure rapid delivery of construction materials to forward engineering battalions. The entire American military machine adapted to support replication of the airfield construction breakthrough. Technical improvements emerged from lessons learned during the initial construction project. Engineers discovered that German concrete, when properly crushed and graded, actually provided superior foundation material compared to natural stone aggregate. The recycling process became standardized, with mobile crushing plants designed specifically for processing bombed concrete installations. Quality control procedures ensured consistent results regardless of local conditions or personnel variations. The broader strategic implications transformed Allied campaign planning for the final assault on German resistance. Air Force commanders now assumed that tactical air support could keep pace with the fastest armored advances, eliminating previous constraints on offensive operations. Ground force commanders developed new tactics that relied on continuous air cover, knowing that engineering capabilities could maintain forward airfield operations regardless of how rapidly the front lines moved. German prisoner interrogations revealed the profound psychological impact of American engineering demonstrations. Many captured officers expressed beliefs that American industrial capabilities were essentially unlimited. The ability to transform destroyed infrastructure into superior Allied facilities within hours seemed to represent technological advantages that made German resistance futile. This demoralization contributed significantly to the collapse of organized German military resistance in the final months of the war. Logistical innovations developed for the rapid airfield construction found applications throughout Allied military operations. Techniques for rapid concrete crushing were applied to road construction and bridge repair projects. Standardized installation procedures for PSP surfaces accelerated construction of temporary bridges, aircraft parking areas, and supply depot facilities. The entire Allied logistics system became more efficient through adoption of methods pioneered by the aviation engineers. The success attracted attention from civilian engineering organizations planning post-war reconstruction projects. Representatives from American construction companies studied military techniques for potential application to highway construction and urban rebuilding programs. The European campaign was demonstrating engineering approaches that would revolutionize civilian construction in the post-war era. Allied propaganda services quickly recognized the public relations value of the engineering achievement. Newsreel footage of the airfield construction appeared in movie theaters throughout the United States and Britain, demonstrating American technological superiority in dramatic visual terms. The images of German concrete being crushed and recycled into American runways provided powerful symbols of inevitable Allied victory. The moral dimension of recycling German construction materials resonated deeply with Allied military personnel and civilian populations. Here was tangible proof that German military investments were being turned against their creators, that Nazi construction efforts were literally providing the foundation for their own defeat. The long-term strategic consequences of rapid airfield construction techniques extended far beyond the immediate tactical victories of 1945. American military planners recognized that the ability to establish air bases anywhere within 48 hours fundamentally altered the relationship between geography and military power. Traditional concepts of defensive terrain became obsolete when any flat area could be transformed into an operational airfield faster than enemy forces could organize effective counterattacks. Post-war analysis revealed that the psychological impact on German military leadership had been even more profound than Allied intelligence initially realized. Captured documents from the German High Command showed that many senior officers had concluded that American engineering capabilities made continued resistance pointless. The demonstration that destroyed German infrastructure could be recycled and improved by American engineers within hours convinced many German leaders that their technological and industrial disadvantages were insurmountable. The techniques pioneered during the German airfield reconstruction became standard doctrine for American military engineers. Training programs incorporated the lessons learned, while equipment modifications improved efficiency and reliability of rapid construction operations. By the end of 1945, every Engineer Aviation Battalion in the American military had mastered the combination of concrete recycling and PSP installation that had seemed revolutionary just months earlier. International recognition of American engineering achievements came from unexpected sources. Swiss and Swedish engineering organizations, maintaining neutrality throughout the war, sent technical observers to study American construction methods. Their reports, published in post-war engineering journals, credited American military engineers with advancing construction technology by decades through innovations developed under combat conditions. The economic implications proved equally significant. American construction companies recognized that military engineering techniques could revolutionize civilian infrastructure projects. Highway construction, airport development, and urban rebuilding programs all benefited from methods originally developed for combat airfield construction. The American construction industry emerged from World War II with capabilities that no other nation could match. German engineering expertise, once considered the world's finest, never recovered from the psychological blow of being surpassed so decisively by American methods. Post-war interviews with German engineers revealed lasting trauma from witnessing their life's work being demolished and rebuilt with superior results in impossibly short time frames. Many German technical professionals abandoned engineering careers, feeling that their expertise had been rendered obsolete by American industrial capabilities. The precedent established by rapid airfield construction influenced American military strategy for decades afterward. Cold War planning assumed that American forces could establish air superiority anywhere in the world through superior engineering capabilities. This assumption shaped defense spending priorities, military organization structures, and strategic doctrine throughout the post-war era. Allied cooperation in engineering projects improved dramatically following the demonstration of American capabilities. British and Canadian engineering units requested technical assistance and training programs to master American construction techniques. This cooperation laid the foundation for NATO standardization programs that would shape Allied military cooperation for generations. The environmental impact of concrete recycling techniques proved surprisingly positive. Rather than creating massive waste disposal problems, destroyed German installations became sources of high-quality construction materials. This precedent influenced post-war urban planning and reconstruction projects throughout Europe, where rubble from bombed cities was systematically recycled rather than simply cleared away. Soviet intelligence services conducted extensive analysis of American engineering achievements, recognizing their implications for post-war military competition. Soviet construction programs attempted to replicate American rapid airfield construction capabilities, though with limited success due to industrial and technological limitations. The engineering gap between American and Soviet capabilities became a significant factor in early Cold War strategic planning. The individual soldiers who accomplished the 48-hour airfield construction returned to civilian life carrying expertise that would reshape American infrastructure development. Many veterans found careers in highway construction, airport development, and large-scale construction projects that applied military engineering techniques to civilian needs. Their experience provided the human foundation for America's post-war construction boom. The symbolism of transforming German military installations into Allied victory platforms resonated throughout American popular culture. Books, movies, and magazine articles celebrated the engineering achievement as representative of American ingenuity and determination. The story became part of American folklore about World War II, illustrating themes of technological superiority and industrial might that defined national identity in the post-war era. International engineering education incorporated case studies of the German airfield reconstruction into curricula worldwide. The project became a standard example of innovative problem-solving under extreme time pressure, demonstrating principles that influenced engineering training for decades. Technical details of the construction methods appeared in engineering textbooks and professional journals, ensuring that the lessons learned would influence future generations of engineers. The transformation of that bombed German airfield in March 1945 represented something far more profound than an impressive feat of military engineering. It embodied the fundamental difference between two approaches to warfare, two philosophies of human capability, and two visions of what was possible when necessity met innovation. German military engineering had been built on concepts of permanence and fortress-like strength. Their airfields were designed to last decades, their concrete mixed to withstand direct bomb hits, their installations planned with Teutonic precision for long-term occupation. This approach reflected a military philosophy that sought to control territory through superior defensive positions and overwhelming fixed fortifications. American engineering represented the opposite philosophy: speed, adaptability, and the assumption that any problem could be solved through the application of industrial ingenuity and human determination. Rather than building installations designed to last forever, American engineers perfected the art of building exactly what was needed, when it was needed, using whatever materials were available. This approach reflected a democratic society's confidence in individual initiative and collective capability. The sight of German engineers weeping as they watched their carefully constructed airfield being demolished recycled, and rebuilt with superior capabilities in 48 hours, captured the moment when one era of military thinking ended and another began. Those tears represented more than professional disappointment. They marked the recognition that American industrial and engineering capabilities had fundamentally altered the nature of warfare itself. The recycling of German concrete into American runways created a powerful metaphor for the war's outcome. The materials that German workers had mixed and poured with such care became the foundation for Allied victory. The strategic positioning that German planners had selected so carefully now served to project American air power deeper into the heart of Germany. Even the engineering expertise that had guided German construction provided intelligence that accelerated American rebuilding efforts. But perhaps the most significant aspect of the achievement was its demonstration that engineering excellence could emerge from democratic values rather than authoritarian discipline. The American soldiers who accomplished the impossible in 48 hours were not following rigid orders or implementing predetermined plans. They were improvising, adapting, and creating solutions to problems that no manual had ever addressed. The airfield they built served Allied forces through the final months of the war, hosting thousands of combat missions that hastened German surrender. Today, commercial aircraft still land on runways built with techniques pioneered during that frantic construction marathon. The legacy of those 48 hours continues to influence military engineering, civilian construction, and our understanding of what becomes possible when human ingenuity confronts impossible challenges with unwavering determination.